Hello and welcome back. In the part 1 of Hadoop setup videos, we set up a virtual machine and installed Java, which was one of the prerequisite for Hadoop installation. In this video, we will look at adding a dedicated user to manage Hadoop, setting up SSH on Hadoop, and also the different modes in which we can set up Hadoop. So after a successful install of Java, we next need to add a dedicated user to manage Hadoop. Now, why is this needed? Now, we have seen that in a Hadoop cluster, the master nodes will need to remotely access the other nodes in the cluster for various reasons, such as, say, to start daemons. Generally, even though we are talking about one node accessing another, more precisely, this access is from a user account on one node to another user account on the target machine. For Hadoop, the accounts should have the same username on all of the nodes, and for security purposes, we recommend it being a user level account. This account is only for managing your Hadoop cluster. Once the cluster daemons are up and running, you will be able to run your actual MapReduce jobs from other accounts as well. So for our setup, we will add a new user called HD user. On the Linux terminal, type the below commands as a root user. This will prompt you to enter the password, so provide a password which you will remember. So confirm the password. Alright, now that you have added the user, provide him access so that the user will also be able to run certain commands as the root user. So let me do that by typing the below command. So this will add the HD user to the sudo group so that the HD user can run certain commands using root access. Now add a group for users who will use Hadoop, which will help you in providing permissions. Here I have added a group called Hadoop. Next, add HD user to the newly added Hadoop group using the below command. Alright, so we have now added a new user called HD user, and I have added him to a group called as Hadoop. Next, we need to set up SSH for the Hadoop cluster. But why is SSH required? When setting up a Hadoop cluster, you will need to designate one specific node as the master node, and this will typically host the name node and the job tracker daemons. It will also serve as the base for contacting and starting the data node and task tracker daemons on all of the slave nodes in the cluster. This is where SSH comes into picture, because the master node should be able to access the slave nodes in a secure manner. SSH utilizes standard public key cryptography to create a pair of keys for user certification, one public key and one private key. The public key is stored locally on every node in the cluster, and the master node sends the private key when attempting to access the slave nodes. With both pieces of information, the slave node can validate the login attempt every time it accesses the slave nodes. However, such a login attempt will prompt for a passphrase to be entered. Since you do not want to enter the passphrase every time the master node contacts the slave node, which in fact happens very frequently, we set up Hadoop with a passphrase-less SSH. When you set up a passphrase-less SSH, you will not be prompted to enter the passphrase during the authentication. Now let us see how to set up passphrase-less SSH. Firstly, let us log in as the user in whose name the Hadoop processes will be running. In our case, it will be the newly added user, HD user. So to do that, I type the below command. The SU command, which is short for substitute user, basically makes it possible to change a login's session owner without having to first log out of the session started by the previous user. Now we'll have a Linux utility which is ssh-keygen, to generate the required keys. And this utility is basically used to manage, generate and convert authentication keys required for SSH authentication. So let's type the below command. Now it prompts you to enter the file in which to save the private key. Just hit enter to choose the default name. This will then successfully create an RSA key pair with an empty password. Let us navigate to the .ssh directory and see what it has done internally. Internally, what this has done is that it has basically created and stored the public and private keys in the .ssh folder of the user's home directory. Let us check that. So here you can see that the private key, which is the id_rsa, and the public key, which is id_rsa.pub. Now let us take a closer look at how SSH works in Hadoop. On our name node, we would have followed the above instructions and generated the public and the private keys. Now if the name node wants to connect to a slave node and start the data node process, it sends its private key to the remote machine. The remote machine then checks to see if the user is authorized by checking to see if the user's public key is in the authorized_keys file in the user's home directory. For this reason, we would need to copy the contents of the id_rsa.pub, which is basically our public key, to the authorized keys file in the home/ssh directory of the user on the remote machine. However, we are setting up Hadoop on a single node, which is basically our virtual machine, right? So the host and the remote machine are the same. So what we'll do is we'll just copy the public key to the authorized keys file, and the command to do that is this. And once we have copied the user's public key into the authorized keys file, it is very important to change the permissions to the SSH folder and also to the authorized keys file like below. chmod 600 SSH. Now what these statements do is basically they restrict the access to the SSH folder only to the current user, and only then your SSH is going to work properly. Now let us quickly test if our passphraseless SSH is configured properly. To do that, type the below command ssh localhost. As you can see, it is prompting for the connection. You say yes. Now as soon as you get these messages, it is very clear that you are able to successfully SSH into the local host, and we can confirm that our passphraseless SSH works fine because you were not prompted for the passphrase. Type exit to close the SSH connection to localhost. See, as you can see here, it clearly says that the connection to localhost was closed. Now with that, we are done with installing and configuring the prerequisites for Hadoop. It is now time to install Hadoop. So let us start off by first getting the latest table release. So this is the URL to find the latest table release. So you click on download, it will take you to the download mirrors, and choose the suggested mirror, which will take you to the files which lists all the Hadoop releases. So in our case, let us choose Hadoop version 1.2.1. Right clicking on that and clicking on open a new tab will open this page wherein you have to copy. This is the file that we are looking to download. So right click and copy link location. Now let us use the wget command in Linux, which is basically a free utility for non-interactive download of files from the web. So wget, and I'll just right click to paste the URL of the file that I want to download. So this will take a couple of minutes to download depending on the internet connection. So let's wait for the download to complete. Now once the download is complete, let us quickly check by listing the directory. As you can see, there is a file called as Hadoop 1.2.1.tar.gz. However, what we have done is we have downloaded it when we are in the folder .ssh. So let's just move this file to the root directory. Or else what we could do is we could move this file to the current user's home directory. So let me just type this command, mv Hadoop HD user. Okay, this is done. So let me go back and then let me check. Yes, there you go. So we have our Hadoop 1.2.1 version downloaded. So now let us extract the zipped files to a folder of our choice. So for the sake of convenience, I will extract it in the home directory itself. So for that, the command is tar-zxvf and the file name. So as you can see, the file is getting unzipped. So once the files are unzipped, let us check the contents of the folder. So let me list the contents of my home directory. I can see a folder Hadoop 1.2.1, and for the sake of convenience, I'll rename this folder to Hadoop. So using this command, and then list the contents of the directory. So now the folder has been renamed to Hadoop. So now let us be a bit more curious and check what is there in the Hadoop folder. So let me change directory into Hadoop and then list the contents of the directory. So as you can see, there are various jar files inside here, and each of them implement certain functionalities of Hadoop. So let us see what is there in the lib folder. There are more jar files here, and each of them again implements certain functionalities of Hadoop. Let us see what is there in the bin folder. Here you can see there are various script files for the purpose of starting and stopping Hadoop daemons. We'll discuss about this in a bit more detail in the later section of the video. And finally, let's look at another important folder, which is conf. So this has certain configuration files required to configure Hadoop. So some of the important configuration files required for Hadoop setup are hadoop-env.sh. Here environment specific settings go. So for example, here is where we configure your java_home environment variable, and you can also specify certain JVM options for various Hadoop components here. And then you have the core-site.xml. This file contains configuration settings for Hadoop core, such as IO settings that are common to both HDFS and MapReduce. It also contains system level Hadoop configuration items such as the HDFS URL and Hadoop temporary directory. Then we have hdfs-site.xml. This contains HDFS settings such as default replication factor, the block size, and whether permissions are enforced. And finally, there is map-site.xml. The MapReduce settings such as the default number of reduced tasks, default min tasks, max task, memory sizes, speculative execution, etc. are all set here. Now, how do these files play a role in configuring Hadoop? Well, when you first uncompress the Hadoop source package, it is ignorant of your hardware setup. So Hadoop chooses to be conservative and assumes a minimal configuration. Hence, all the three core XML files, that is core-site.xml, hdfs-site.xml, and mapred-site.xml, are empty under this default mode. So why don't we check? As you can see here, we have the hadoop-env.sh, the core-site.xml, hdfs-site.xml, and mapred-site.xml, which are our core files that need to be configured for setting up Hadoop in different modes. Now let me edit the core-site.xml to see the contents of the file. The core-site.xml is in the conf folder. So as you can see, it is empty. That is, they do not have any properties configured under the configuration XML tags. Similarly, let us check for the hdfs-site.xml. This is also empty. And finally, let us check mapred-site.xml. This is also empty. Now, with empty configuration files, Hadoop will run completely on the local machine. And this mode of Hadoop is called as local mode or standalone mode. The standalone mode is the default mode for Hadoop. Here, because there is no need to communicate with other nodes, the standalone mode does not use HDFS, nor will it launch any of the Hadoop daemons. Its primary use is for developing and debugging the application logic of a MapReduce program without the additional complexity of interacting with the daemons. Now, Hadoop in production runs as a fully distributed mode, where you will have multiple machines set up as nodes and the master processes running on separate machines. However, what we intend to run as part of our class is called as pseudo distributed mode, which is essentially a Hadoop cluster of one node. Here, all the Hadoop processes are running on one machine. This mode is also typically used for development and or testing. So those are the different modes in which you can configure Hadoop. So we'll get into more details about setting up a Hadoop single node Hadoop cluster on a virtual machine in the next video. Thank you for watching and stay tuned.